Alright, so solving problems that involve charge, capacitance, and voltage. So for these problems, you want to know that Q equals CV. That's kind of like a prerequisite kind of formula that you're going to have to keep in mind. And so that's something you're going to have to remember. But let's see about ways that we can make it easier for ourselves, okay, to solve for each and every one of these. So there's one method is you can arrange, so Q equals CV. So if we're trying to find for V, right, and we're going to keep V on one side with the equal sign, you got to just divide by C, right, by both sides. So these two cancel out and you get V, and that equals to QC. And now it's the same thing if we do it with, if we're trying to find the voltage, or just to keep the coulombs on this side, right? We're going to have to divide by V to get rid of the V, and you do the same thing to the other side. These two cancel out, and then you get C equals to Q over V. Okay, so an easy way to do this, right? And it's used by many people, especially in the engineering space. If you've heard of V over IR, right? And this pyramid, if you've seen this before, you can use the same principle for this, right? You can do something like Q at the top, and then in the pyramid at the bottom, you have the C and the V. Okay, and these two are interchangeable. These two are interchangeable at the bottom, right? The way you want to solve these is you want to go, okay, so if we're trying to find for Q, right, these two are beside each other, so we just multiply them. Okay, so now if we're trying to find for C, right, what we do is we have Q at the top, and it's over, this is the division sign, right, that we can imagine, over V. So Q over V, and that's the formula. And now it's the same thing for if we're trying to find V, right? We have Q on top, and it's over, right? We're using this over here, and it's equal to C, or it's over C, and that equals V. That's kind of like the basic prerequisite information to solve these kind of problems. So now let's go back to problems here. Let's go to the problems. A capacitor stores 85 microcoulombs of charge when 15 volts is applied. What is its capacitance in microfarads? So you also need to know that C is coulombs, right? So Q, and then capacitance is measured in farads. Okay, so in this question, let's write the pyramid out, and I'll do this for every question. Q is on the top, and then V and C are at the bottom. Okay, so now we can use this to solve, or use what we know to solve this problem. So we're trying to find for capacitance, okay? So C. So C over here is equal to Q over V. Okay, so now let's center this a little bit, and let's plug in the values. Okay, so equal sign, we have the coulombs, so 85, and then over 15. And you want to make sure this is same unit, okay? You want to make sure the units are correct. And now what you can do is you can always convert this into coulombs, right, instead of it being microcoulombs. But you should get the answer, right? If we're trying to find the answer in micro, then there's no need to do the conversion here, right? But if it was the case, I'll explain after we solve this, right? So let's get the calculator out. 85, so 85 divided by 15. And the answer is 5.67. Okay, 5.67 microfarads. F is always capital. Now, let's say the question said you want to find its capacitance in farads, okay, right, instead of this. What you do is you try to convert it. So now there's different ways of converting it. I think the easy way, at least for me, I found is just to move the decimal place. So I know that in my head that micro is -6. It's 10 to the -6. Okay, so -6 is the same thing as moving the decimal place to the right. Okay, so in this case, we were trying to do the inverse. We're trying to go up, so we'd go to the left. So if that made any sense, let's move this board a little bit, and let's see. Let's do 8.67, right? And we're trying to go left 6. Okay, 1, 2, 3, 4, 5, 6. and these holes are going to be here. Okay, and then the period is here, right? And so what we have here is we have the answer as 0 0.0, 1, 2, 3, 4, 5, 6, right? And then, oh, there's no period, sorry. And then the 67 over here. And this is in farads. So that's kind of how I would do the conversions. You can always do the math where you have the 10 over 6, then you do the other stuff, right? And that makes it a little complicated. I just like to move the decimal place. It's just easier for me. But use whatever you may deem to do that. Now we have this question. I'll go a little faster now since we know how to apply it. A 4.7 microfarad capacitor has 12 volts across its plates. How much charge does it store? So let's do the pyramid here. Q, and then we'll do CV, okay? And so what we have is capacitor or capacitance and its voltage, and we're trying to find Q, so let's write Q equals CV, okay? And now what we can do is we can just apply the values or plug in the values. So let's do 4.7, right, micro times 12 volts. And now we can put this in a calculator. Okay, so let's do that. 4.7 times 12. And we get 56.4. And you want to make sure that you have the same units, right? So because we did microfarads, and this is normal, right? The answer is going to be in micro. So the answer is in microcoulombs. So 56.4 microcoulombs is the answer. Okay, so now we got that. And I hope you guys are getting it. But now let's go to this question. Determine the voltage across the 0.1 microfarad capacitor that is storing 5 microcoulombs of charge. Okay, so what are we trying to find? We're trying to find the voltage. So Q, CV, right? Right here, what we're trying to find is voltage. So we know that Q and C, right? Q over C is the formula we're going to use. So V equals Q over C. And now let's plug in the values here. Okay. Let's do 0.1 at the bottom, and then the charge is at the top because charge is Q, 5. Okay. And now I'm not putting actually I'll do this. I'll put the micro sign here just to explain the point that if you have 2 micro, right, these two cancel out in the division. And now you have 5 over 0.1, and that's going to be given to you in normal volts, right? It's not asking about give the volts into what unit. So let's just put volts in as like a general thing to do, okay? And so if we get the answer here, so let's do here, let's get the calculator out. 5 divided by 0.1, that gives us 50. So now we're getting 50 volts. All right. And if you do the conversion, right, if you go 6 to the left, then you should get 50 volts as well. Okay. And that's the basic questions of how to solve voltage with capacitance and charge. Thank you for watching and have a great day. Bye.